From next class, you have to be on time. Probability and statistics. Okay. Probability and statistics. Okay. These are some of the important topics that do you take in case of probability and statistics. Okay. So just make a note of all these points. Okay. So that it helps you whenever we are taking these things. Okay. First one, it will be conditional probability. First one, it is conditional probability. Second one, conditional probability. Second one is random variables and expectation. Random variable and expectation. Random variable and expectation. And the third one is your binomial distribution. Okay. Fourth one. Fourth one and fifth one is most important topic. That is your normal distribution and Poisson distribution. Okay. I am telling you 100% there will be a question on normal distribution and Poisson distribution. Okay. Just make a star mark with this. You have to practice n number of questions with respect to normal distribution and Poisson distribution. Okay. Next one, exponential distribution and joint distribution. Okay. Last two topic. Last one is your statistics, and last topic is your statistics. In statistics, we have last thing is correlation and regression analysis. Okay. Correlation and regression analysis. Okay. Only for EC branch you have hypothesis testing. Okay. No other branch need not write hypothesis testing except EC branch. EC branch has hypothesis testing. Okay. Next, differential equation. See, I have given you all these things. Okay, you know, probability will start with your, there are only three cases. I mean, three general problems we have as usual. That is our coin problem and our dice problem and our 52 cards problem. Okay, 52 cards questions are very less as per gate is concerned. But in, except in 15 years, we have not got more than 3 or 4 questions. Okay, but normal distribution every year we get question. Okay, normal distribution and binomial distribution. Okay, next is about your all these distribution. You know, it starts with your whenever your number of samples increases, it goes on increasing. Okay, we have so many type binomial distribution, Bernoulli distribution, all these things. Okay, various applications we are using. Okay, so hence probability statistics, except normal distribution and Poisson distribution, you don't get much questions from this. Okay. Uh, Next, it is about your differential equation. Probably everyone have noted these things. Next is your differential equations. Okay. Yesterday we have stopped at matrix algebra. We'll continue after we complete this detailed introduction. Okay. Differential equation. First one is your first order differential equation. First order linear differential equation. Next is your higher order linear differential equation. Okay. First question is about your first topic is all about your first order differential equation. Next topic is about your higher order LDE. LDE is nothing but your linear differential equation. Okay. So generally it will be in the format of dy by dx plus py is equal to q. Okay. I think probably you have heard linear differential equation. Yes or no? Linear differential equation is a concept based on your both integration and your differentiation. Okay. Interrelation it will have. So probably you have seen find the general solution, separation of variables, y is equal to vx. All these are the various methods. ODE, ordinary differential equation, partial differential equation, various methods, Jacobian, so many concepts you have. Okay, all these you have studied in your engineering. Okay, next is method of variation of parameter. Okay, the third concept is about method of variation of parameter. Okay, fourth one, make a star mark, Euler-Cauchy homogeneous linear equation. Okay, this is most important type. Usually, alternate years we get question on Euler homogeneous equation. Okay, Cauchy-Euler or Euler-Cauchy. It is the same. Okay, homogeneous differential equation. Okay. Next is your PDE, partial differential equation. And last one is about your Laplace transform. Once in 3 years, we get one question on your Laplace transform. Okay. Next. Understood? Differential equation is always related to your basics, first order differential equation, higher order differential equation, method of variation of parameter, and Euler-Cauchy homogeneous linear equation, most important topic, and your partial differential equation. Last one is your Laplace transform. Once in 3 years we get. Okay. Then complex variable. Okay. Complex variables. This is, I have given you yesterday the marks weightage. Okay. Complex variable maximum it has 1 to 3 marks. First one is your analytic function. We'll analyze how you're analyzing whether it is analytic function or not. Okay, probably you'll come to know. That is, as usual, you will have the introduction for complex variable and then we'll start with your analytic function. Okay, next part is your Cauchy integral theorem, and last one is your Cauchy's residue. Okay, residue also there is an important topic. Okay, regarding residue. Okay, Cauchy integral theorem, Cauchy residue, analytic function, and complex integration is also there that we have taken in case of your calculus itself. Okay, so you need not think. Okay, last one, the easiest topic in case of your engineering maths is your linear algebra and your numerical methods. Okay, take down numerical methods, some 3 or 4 topics you have. Numerical methods, don't leave this numerical methods. Okay, it's very easy. Okay, numerical solution of nonlinear equations, numerical solutions for nonlinear equation. Second one, numerical solution of differential equation, numerical solution to differential equation, and the third one, Lagrange's interpolation. See, probably you have studied in your third sem Lagrange's interpolation formula. Okay. And probably you have heard of divided differences. Yes or no? That is your Newton's divided interpolation polynomial for unequal intervals. Okay. There is no direct question as far as your Lagrange's and your Newton's divided interpolation formula. Okay. But we are have 2 years once we get one some question from the numerical methods, that too from your Newton's interpolation with equal intervals and unequal intervals. Okay, this is based on your divided differences. Okay, understood? So we have completed a detailed introduction about all the topics that we have. So probably these some topics may be familiar to you, some topics may be new to you. Okay, we'll go with a very normal speed. And keep in mind, the next week I'm having the class. Okay. Don't forget to go through the class when you are attending in tomorrow. I mean, in the next week class, you just go through the class and come. Okay. When you are attending your Saturday's class, because there will be 1 week gap. Okay. So we stopped at matrix algebra, probably if I remember. Yes or no? Hello? Yes or no?
Yes,
Yes.
sir.
So you know that addition and subtraction, as usual, we know that you know about the your addition of matrix, addition of I mean subtraction of matrix. There are no condition for addition and subtraction is concerned. Okay, but as far as multiplication is concerned, you know there are two conditions that has to be satisfied in order to multiply any two matrix. What are those? Suppose you are multiplying A dot B. Okay. Suppose your A is M cross N and B is your P cross Q. Okay. So what is the first and foremost condition? N must be equal to P and your multiplied matrix will be definitely your M cross Q. Okay. So there is no condition that it has to be same order and same column. Okay. In case of multiplication. Basically, you can multiply with 2 cross 4 with 4 cross 100 also. Okay. There is a possibility. You will get 2 cross 100 matrix. Okay. This is just a typical example. Okay. Keep in mind, in addition, we have this possibility. Okay. Next. Before that, we are having scalar multiplication also to a matrix. I think you know, suppose you are given with, uh, you can just take, suppose your A is equal to 1, 2, 3, 4. Yes or no? So you can do, there are some properties with respect to scalar multiplication. So you can find out 2a, you can find a by 2, you can find a by 3, so on. Okay. Scalar multiplication of, there is no division. So keep in mind, in algebra of matrix, we have addition, subtraction, multiplication, and your last one is your inverse. There is no concept of division. Okay. In matrix, you cannot divide one matrix by the other. Please keep in mind. Okay. Only inverse is possible. Okay. Next. So we are having some properties with respect to your addition and subtraction. You know, some are commutative, some are associative, all these things. But in case of your, uh, we'll take up that. Uh, First of all, existence of additive identity. Okay. If they ask you, see, I am just explaining you just for the knowledge sake. Okay. Additive identity. What do you mean by additive identity? A plus O that is equal to O plus A. Okay. Just make a note of all these points. Okay. Additive identity is nothing but A plus O or O plus A is equal to your A because your O is a null matrix. Okay. Usually we represent with Z or O. Okay. Null matrix. All the elements in the matrix are zero and hence they are called null matrix. Understood? Hello. I know this is a Sunday afternoon class. Somehow you have to adjust. You are already in weekend mood. I know. Fine. Next is about your existence of additive inverse. Okay. What do you mean by additive identity and additive inverse? Okay. Existence of additive inverse is all about, suppose A plus of minus A that is equal to minus of A plus A that is equal to O. That is called additive inverse. Okay, minus A is called additive inverse of the matrix. Okay, understood? Okay, fine. Next, the multiplication is having some properties. Yes or no? That is all about your multiplication is about associative. Whether your a normal multiplication of matrix can it be commutative? Except one case. In all cases, does it prove? No, your multiplication of any two matrix does not obey your commutative law. Okay, so keep in mind, except in additive inverse. Okay, except that you don't have that. I mean, multiplication of matrix cannot be commutative. Okay, except in special cases, and say that your A dot B not equal to B dot A, but it is associative and it is distributive also. So that is your A dot B into C that is equal to A dot B. Sorry, I wrote the same. A dot B into C is equal to A dot B dot C. And your distributive is all about, suppose A plus B into C that is equal to your AC plus AC plus BC. Okay. Finally, your matrix multiplication is associative and it is distributive in case of your matrix multiplication. Okay. So we have only this much concepts is related to your matrix. Okay. Next is all about, we'll take up questions. Okay. We'll take up some problem, I mean theory part related to your determinants, and then we'll go for your problems. Okay. So today we'll have some more questions. Okay. Then I'll stop at that point. Okay. Okay. Fine. Determinants. Have you heard of determinants? I need answer. Team members are there. Okay. Fine. What do you mean by determinant? Determinant. Can anyone turn on your mic and tell what is determinant? Don't tell me if you just write determinant A, that is determinant is just the extension of your matrix. Okay. In case of matrix, you are not able to get the exact value of matrix. In case of determinant, you can get the exact value of determinant. Okay. 2 cross 2 and 3 cross 3. Okay. Because in case of matrix, probably if you remember your 12th syllabus, you are able to get the inverse using the normal row and column operations. Yes or no? You used to do it with the help of your A is equal to I dot A. Probably if you remember, you know that. Yes or no? You will write A matrix and you will write the identity matrix. What all operations you do on the LHS, you have to do all the operations on the right side and you have to get the identity matrix on the LHS part and then you will get the inverse. So that we are not, that we need not study in case of your gate. Okay. We are having only matrix, algebra we have studied and these things, what all I have stopped. Okay. Inverse comes under your determinants concept. Okay. Normal getting inverse is not there in your gate. Okay. So, and you know that it is a multiple choice questions. So there will be no theory questions as far as gate is concerned or any competitive exams. Okay, in the level one. Okay. Next is about your determinants and inverse. Okay. Determinants is nothing but the extension version of your matrix, and you will be enclosing the matrix with the, you are enclosing the matrix with square brackets. Whereas in case of determinant, you just uh, enclose within the two straight lines. Okay. Yes or no? That is called your determinant. That is your A11, A12, A21, A2. Okay. This is all about and how to get exact value of the determinant. Probably all of you know A11 into A22 minus your A12 into A21. Okay, that is in case of 2 cross 2. And the famous formula for A inverse is nothing but 1 by determinant of A into adjoint of A. Okay. I'll take up one problem with respect to inverse in a regular method. Okay. So probably who have lost their touch, probably they've come to know. And one 3 cross 3 extension also I'll show you. Okay. But don't use the regular method as far as gate is concerned. Okay. Uh, since some people have told me that give one normal problem and then we'll go for your order, your gate questions. Okay. So you know this is your 2 cross 2. Okay, you can substitute any 1, minus 2, 3, and 4. So it is definitely your 4 plus 6. Okay, you have this minus sign from the formula itself. So 6 plus 4 is definitely equal to 10. Okay. Wait, determine. Okay. So now I think you know about next one. We'll go for your 3 cross 3. Okay. Determinant of square matrix of 3 cross 3. How do you represent it? As usual, that is your A11, A12, A13, A21, A22, A23, and your A31, A32, A33. Okay. Uh, you know, you can expand determinant using any row or any column. Okay. It doesn't matter. Okay. You will get the same answer. Okay. Whether you expand through rows or you expand through column, it is the same thing. Okay. Probably you have studied how will you expand a normal determinant. That is uh, A11 into eliminate that row, that column. Okay. Then you can just take A22, A23. Since one student messaged, I am doing this. Otherwise, probably you have to remember these things. Okay. So eliminate minus A12 into 2 cross 2. That is your, as usually, A21, A31, and your A23 and A33. Okay. Plus your A13 into again the 2 cross 2. That is A21, A22, and your A31 and your A32. Okay. So this is an ordinary 2 cross 2 expansion. Okay. Of your 3 cross 3 determinant. We'll take a problem. I don't have patience to write A22, A33 minus A32, A23, all these things. We'll take up in problem and I'll expand through first row. You just expand through first column and check whether you are getting the same answer or not. Okay. This is your expansion. Probably the 14 members online understood how to expand. Anyone has any doubts?
No, sir.
So this is your 1, 3, minus 2, 4, 5, 6, 7, 9. Okay. As usual, 1 into 5 2 is 10. 10 minus, I'll write this 10. Okay, fine. 10 minus 9 6 is how much? Yes, 10 minus 54, and this is your minus 3 into 4 2 are 8 minus 7 6 is 42 plus 2 into this is 9 4 is 36 minus your 7 5 is 35. Okay, you have minus 2 here, so you have to just take that sign. Okay, plus of minus 1 is minus 1. Okay, here you have minus 2, keep in mind. But according to our expansion formula, we have to take a plus. Plus into minus is minus, so I have written minus 2. Okay, don't expect these things in the future. Okay, so 10 minus 54, what is your final answer? Minus 44 minus 3 into 8 minus 42. What is it? Minus 34 minus 2 into plus 1. Yes or no? Then this becomes minus 44 plus 3 into 34. Yes or no? This becomes 1 or 2. This is minus 2. 100. 100 minus 44. Definitely you are 56. Understood? First problem, I have taught you how to get the determinant value. Okay, for the people who have who are not in study background, or for those I have shown you one problem. Okay, understood? You expand through the first column and check whether you are getting the same answer. Hello?
Same answer, sir. Same answer.
Yeah, fine. Yes, next. See, inverse, as far as inverse is concerned, you are 1 by determinant of A into adjoint of A. See, I'll show you one problem how to get inverse. Okay, one problem in detail. then I told you, no, we are not able to do with this method. Okay. So what is your adjoint? Adjoint is nothing but your cofactor matrix transpose. Okay. How do you get the cofactor matrix? For the minus. Okay. With the sign convention, if you just multiply for the minus, you will get cofactor matrix. Okay. And minus, how do you get it? You consider the first element and eliminate that row, that column, and then proceed. Okay. Yes. So we'll do one problem in detail. Okay. And keep in mind, adjoint of A and we are having some properties with respect to adjoint. Okay. A into adjoint of A into A, that is equal to I. That is your identity matrix. And also keep in mind, identity matrix is always represented with I. Okay. We'll take up one problem. That is your first one. And keep in mind, if your determinant value is 0, does your A inverse exist? As far as your gate is concerned, you don't have to study that topic. Okay. I mean, even though your determinant is 0, you can get the value of inverse in the future. Okay. Probably in engineering, you will come to know. Okay. We are having so many methods to analyze, and we have the extension part of that. Okay. As for now, you think that if your determinant is 0, you are not able to get the inverse of any matrix. Okay. First of all, you know A inverse is equal to 1 by determinant of A into adjoint of A. So we'll take up one problem. That is here 1, 1, 5, 3, 2, 1, 7, 1, 0. Okay. So we have to get the inverse of this. What is the first and foremost thing? Check whether your determinant A exists or not. Okay. So that is your 1 into 0 minus 1 minus 1. Okay. So this is again minus 1 into that is 0, 0 minus 7 minus 7. Last one, that is plus 5 into 3 minus 7 twos are 14. Okay. That is 3 minus 14. That becomes 3 minus 14. That becomes minus 11. Okay. So definitely this is your minus 1. This is your plus 7. And this is your minus 55. What is your answer? Minus 49 is your answer. That is your determinant. Okay. Adjoint of A, I'll write it directly. Okay. Adjoint of A, I'll show you one minor. Okay. M11. Okay. How do you get the minors? You represent it with 1 1. Okay. You have to eliminate that row, that column, and finally you will get 2 1 1 0. Okay. So this becomes 0 minus 1 minus 1. So you can do it and write it in your book if you want. Otherwise, we'll do it directly as adjoint of A. Okay. What is your adjoint of A? That is your plus minus plus minus plus minus plus minus. Okay. So you'll write the sign convention and then you write go on writing your minus. Okay. First one we have already got, that is your minus 1. Okay. Next one, that is your 1. Okay. So eliminate that row, that column. You'll get 0. 0 minus 7. That is minus 7. See, I'm writing directly, I'm just taking transpose because what do you write in your normal case? You write the minors, then you take the sign convention, then you take your transpose of that, yes or no, cofactor, then you write your transpose. That will be your adjoint. We are doing it directly. Okay. So I'm writing your A2, A12 as directly as A21. Okay. So last one, that is your 5. Okay. That is 3 minus 11. Okay, you will have minus. Next one, you are considering 3. So that is 1 into 0 is 0. 0 minus 5 is minus 5. Okay, next one, you are considering 2. Okay, you are 1 into 0 is 0. 7 5 is 35. That is minus 35. And last one is 1 into 1, 1 minus 7. 1 minus 7 is minus 6. Okay, last one, that is your 1 minus 10. 1 minus 10 is minus 9. Okay, last one, I mean, before last, 1 into 1, 1 minus 5 3s are 15. That is minus 2. Okay, finally, last one, 2 minus 3. 2 minus 3 is yes. So finally, what is your adjoint of A? We have got it. And A inverse is equal to 1 by minus 49 into your minus 1. Then this is your plus 5. This is minus 9. And this is your plus 7, minus 35. And this is your plus 14 because minus into minus will become plus. So this is your next is minus 11. And this is your plus 6. And this is minus. Okay. Understood? Am I too fast? You understood what is adjoint? How to get the inverse in a normal way? Hello?
Yes, sir.
Since this is the first problem, I showed you in a direct way. Okay? Okay. Next. So probably you know about your minors and cofactors. Okay. What do you mean by singular matrix? Determinant is 0 means your singular matrix. Okay. A square matrix is said to be singular if your determinant of A equal to 0, then they are called as singular matrix. Okay. Next, non-singular matrix. What do you mean by non-singular? As usual, your A of n cross n not equal to 0, then it is said to be as non-singular matrix. Okay. Next, uh, some properties we have as far as adjoint is concerned. Okay, just make a note of it. Okay. If A is a square matrix, if A is a square matrix and you know it is always of the same order. Okay, so your adjoint of matrix is nothing but A into adjoint of A is equal to adjoint of A into A, that is equal to your determinant of A into. If A is a square matrix of order n, then A into adjoint of A and A into adjoint of A into A is also equal to your determinant A into In. Okay, n is your order of a matrix. Okay, that is your identity matrix. Okay, what is adjoint of null matrix? 0. Okay, and what is your adjoint of In? That is In itself. Okay, yes. Next is about your properties of your inverse of a square matrix. Okay, what are the properties that we have in case of square matrix? Determinant should exist. That is your first property. If your determinant is equal to 0, then your A inverse doesn't exist. And you know that if A, B, C are your non-singular matrix, if your A, B, C are called non-singular matrix, then your A, B whole inverse, that is equal to your B inverse into A inverse. Okay, this is proved also for your A, B, C. Okay, keep in mind C inverse, B inverse to A inverse. Okay. Understood? Shall we go for problems?
Yes, sir.
The value of determinant. This is gate 94. The value of determinant 149, because I have to know whether you understood or not. This is gate 94. 9, 16, 25. Don't expect these questions. Okay. So this is your option A, 8. Option B, minus 12. Option C, 12. Option D, minus 8. Out of 14 members, anyone are expecting me to do this problem? You can do it and tell me the answer. Probably I've taught you how to do it. Okay. Just for the sake of first problem we have given. Okay. What's your answer? No answer. This much time you need. Super. Let them try. We have not done your properties of your determinants. We have stopped. We have to go still. I mean, if any two rows or any two columns are zero, we have to take up all those properties. We have not taken. No answer. Why? Minus 8. Yes. So I'll show you. This type of question doesn't come. 25 into 9. It is 225. And 16 square is 256. 225 minus 256 minus 31 minus 4 into, yes, minus 4 into 4 into 25, that is 100. 100 minus 9, 69 is 144. 69 is 100 minus 144 is minus 44. So plus 9 into, this is your 16 fours is 64. 64 minus 81. Okay. Finally, you will get answer as minus. Option D is your answer. Next, gate 2000 question. Yeah, minus 8.